Okay, I'm going to start with just demonstrating that my Space Invaders project works. Yeah. And moving on to the actual assignment for this week, implementing the data manager. I'm going to start with, for this, also just demonstrating the demo that I've wrote in the main program. So if we look at this, I start with adding 3 nodes, 2 to the front and 1 to the back, and we can see that the node Joe, despite being added last, is indeed at the back here, in front of, behind Billy, which was the first node added to the front. And so the next step is to remove the node Billy, and we can see here that, well, firstly, I guess, after adding the 3 nodes, we can see that the reserve list was properly refilled with 3 additional washed nodes. And like I was saying, the remove of Billy, as you can see, another node was just added to the reserve, and there's no Billy. And the next thing is adding 2 more nodes, 1 to the front, 1 to the back. And we can see that that is done right here, basically surrounding the original nodes. And the last step of the demo is to demonstrate the find function, and we can see that it does indeed find the node Bob right here. Okay, so moving to the actual implementation, I implemented my manager as a singleton, just because that's where we're heading. And you can see that this function right here is required to be called in order to access any of the public API methods of this class. This method isn't extraneous, but rather just something I'm still deciding if it's a good design or not. But moving on to the actual assignment, when the data manager is created, an initialize function is called, which restocks the reserve with the initial reserve size amount, and that's done by just simply creating the inactive d-links. And we can see I create a node, a derived node, and I simply just add it to the front, giving the head and tail of the reserve list. And just to briefly show that implementation, it's just basic linked list, adding a node to the front, and then also adjusting the stats properly. So that's how nodes are added to the reserve when it needs to be restocked. When we want to add a node, when the user wants to get a node from the reserve list, what we do is we activate the d-link, and that's done right here in this method. And you can see here that I am removing from the reserve list by passing in the reserve head and tail and calling the static d-link remove method. And then with that node that's returned from this static method, I add that to the front of the active list, passing the active head and tail to this d-link add to front method, static add to front method. Okay, and lastly, for the remove, the way this works is, once again, I access the private method behind the public API. I wash the node regardless of whether if it was created. I wash the node when it's returned to the data manager. So that way the reserve list always has washed nodes on it with no dangling pointers, essentially. And once again, the same kind of convoluted pattern of just like on one line, but I remove the node from the active list, passing the active head and tail, and I add it to the front of the reserve list, passing the head and tail. And so this is the node that will be added to the reserve list.